Hi everyone, how are y'all? Happy Easter Sunday! Well, I'm recording this on Easter Sunday, so happy Easter Sunday, because you'll obviously be watching from the future. My name is Vicky Chancellor Prosper, and I am your Miss University of the Bahamas. So I created this video to try to help you prepare for your assessment. So without further ado, let's get into it! Okay, so Math 167 Test 2, let's get right into it. Given the graph of the function f of x below, determine the following x-intercepts. So we know the x-intercept is where the graph touches the x-axis where y is 0. So it does that at negative 2.2, 0, and then 2.2. See these points. And we listen the x values. So negative 2.2, 0, 2.2. Same thing for y values, except it touches the y values where x is equal to 0. And that only happens at 0. Our absolute minimum value is, we only have one, that's 6.5. That's negative 6.5. Negative 6.25, sorry. And our absolute maximum value is 10. We have one, that's just 10. List the intervals where the graph of the f of x function. List the intervals where the graph of the function f of x where f of x is greater than 0. So where y is greater than 0. So we're looking at all the values up here. We list them in terms of our x values. So you see it start here at negative 10. So we have negative 10 up to negative 2.2. That's negative 2.2 here. This is where the graph is greater than 0. So negative 10, negative 2.2, union, because you see there's a little break here where it goes below the graph, but it comes back up above the graph. And we're listing our x values. So we have 2.2 up to 10. So we have 2.2, 10. F of x is less than 0, so that's where the graph is less than 0. So again, we listen to x values. So we have negative 2.2, 0, union 0, 2.2. Negative 2.2, 0, union 0, 2.2. Okay. Increasing. Increasing, so that's where the graph is like going up, like you can see going up. So again, we're listing our x values. So you see it increasing here at negative 1.6 up to 0. And then again here at 1.6 up to 2.6. You're going all the way up here, up to 2.6. So negative 1.6, 0, union 1.6, 2.6. So you don't just put them side by side. You have to make sure you put the union sign between them. Decreasing is where, you know, they're going down. So it's going down from here. That's negative 2.6 all the way down here to negative 1.6. And then again at 0, 1.6. Constant is just where it's going in a straight line, like you see here. So that would be negative 10, because it's the point for negative 10, see down here. Negative 10, negative 10 up to negative 2.6. Union 2.6 positive 10. So is the graph even, odd, or neither? Our graph is even because you see if you fold it in half on the y-axis, you get the same exact thing. So it is even. And when it's even, it's symmetric in respect to the y-axis. The range you're looking at, when you want to determine the range, you're looking at all the values of y that the graph covers. So you start at the negative value, that would be negative 6.25 all the way up to positive 10. Okay, that's our first page. Okay, let's go down here. So draw a complete graph so that it has origin symmetry. Okay, so when you want to graph up origin symmetry, for every point x, y on the graph, there's also the point negative x, negative y. So that's how you know the graph has origin symmetry. So let's find the points that are on this graph that we could actually locate. So we have 0, 0. We have, you can see it goes in terms of 5. So there's 5, 10, 15, 20. So let's write it. That's 5 and then negative 5, 10, and that's it. Yeah. So this point would be 5, negative 5. And then the next point be down here. That's 10, negative 20. So if the point x, y is in the graph, if the graph's of origin symmetry, then the point negative x, negative y would be on the graph. So all we have to do is multiply all the coordinates by negative 1. So now we have, this would be 0, 0. This would be negative 5, positive 5. This would be negative 10, positive 20. Okay. So now let's write 5, 10, 15. Okay. So now plotting 0, 0. Okay, and then negative 5, 5. Okay, I forgot to plot up here. So you have 5, 10, 15. So you have negative 5, 5 right here. And then we have negative 10, 20 right here. So we just connect the lines. Okay, and there you have it, origin symmetry. Okay, is the following equation symmetric with respect to the y-axis, x-axis, or origin? Give reasons. Okay, since you see even numbers here, I would say you automatically know that's how it's symmetric with respect to the y-axis. Because in order to test for symmetry with the y-axis, you would have to replace x by negative x and simplify. If it gives you the same result, then it's symmetric with respect to the y-axis. We know when we raise any negative number to an even power, it's positive. So if we raise negative x to the power 8, that's positive. If we raise negative x to the power of 4, that's positive. So it would give us the same exact equation. So that's how we know it's symmetric with respect to the y-axis. But still, let me show you. Replace x by negative x. So y is equal to negative 3, negative x to the power 8 minus 5, negative x to the power of 4 minus 100. Now simplify it. That's y is equal to negative 3 x to the power 8 minus 5 x to the power 4 minus 100. That's the same exact equation we started off with, so it's symmetric with respect to the y-axis. If you wanted to test for symmetry for the x-axis, all you have to do is replace y by negative y. And we know if we to do that, it'll be a different equation, because you can't simplify. If you just replace this y with negative y, you can't simplify that no more. It's just that. So if you want to test for symmetry with x, replace y by negative y. If you want to test for symmetry for y-axis, replace x by negative x. And if you want to test for symmetry with the origin, replace x by negative x and y by negative y. I'm supposed to put it is symmetric with respect to the y-axis. I didn't realize I didn't put that. So, yeah, be mindful of that. Okay. So, next question, find the domain of the following function. So, this is the difference of two squares. And the formula for difference of two squares is a squared minus b squared is equal to a minus b, a plus b, right? So, this is x squared minus 6 squared. So this is x minus 6, x plus 6. And we're going to set them equal to 0. Well, not equal to 0. So we have x minus 6 is not equal to 0. It's not equal to 0. X plus 6 is not equal to 0. Now let's solve for x. X is not equal to 6, and then x is not equal to negative 6. So we don't want 6 and negative 6 to be substituted into this, because if it is, it's going to make it 0. You see? If you substitute 6 for here, and this becomes 0, you know 0 times 0 is 0, and then our denominator will be 0. And that would give us an error, because the denominator cannot be 0. Okay? But we have a square root function too. So we have to deal with that, because we also don't want our square root function inside here to be a negative number, because that is also going to give us an error. Because squaring a negative number, it gives you an unreal number. Okay, so now what we're going to do to solve that is 8 minus 3x. We're going to set it greater than or equal to 0 and then solve for x. So you have negative 3x is greater than or equal to negative 8. When you divide by a negative number, you flip. So we divide it by negative 3. So x is less than or equal to 8 over 3, positive 8 over 3, because you see you're dividing by a negative number. So you see, we don't want our x value to be 6. We don't want our x value to be 6. We don't want it to be negative 6. And we want our x values to be less than or equal to 8 over 3. If it is anything different, it would give our function a negative number, and we don't want that. Okay? So, to write that in interval form, that is negative infinity up to negative 6, union negative 6, 8 over 3. So this is saying our values are between negative infinity and negative 6, and then negative 6 up to 8.3. And this is our answer. Okay, so find the distance of the line segment joining P1 and P2. So remember our distance formula. D equals the square root x2 minus x1 squared plus y2 minus y1 squared. And we can just substitute our values in. So D equals, so this is equal to negative 2 minus negative 6. A lot of students make this mistake and just put minus we have a minus here, and then we have our negative 6. So negative 6 is being subtracted from negative 2. So you have to make sure put it in brackets when you have something like that. Plus y2, which is 2 minus 11. And don't forget our squared. So d is equal to, that's negative 2 plus 6, because the negative times negative is a positive, plus negative 9 squared. So this is equal to 4 squared plus negative 9 squared. So this is equal to 16 plus 81. D is equal to the square root of 97. Okay. Find the midpoint from P1 and P2. X1 plus X2 divided by 2. Y1 plus Y2 divided by 2. Okay. So X1 plus X2. So that's negative 6 plus negative 2 divided by 2. 11 plus 2 divided by 2. That's negative 6 minus 2, because a negative times a negative is a negative times a... This is minus 6 minus 2, because a negative times a positive is a negative. So minus 6 minus 2, that's negative 8 divided by 2. And then this is 13 divided by 2. So m is equal to negative 4, 6.5. Okay. Find the equation of the line that contains P1 and P2. So first thing we're going to do is find our slope. Remember, our slope formula is y2 minus y1 divided by x2 minus x1. So we're going to find our slope. So that would be 2 minus 11 divided by negative 2 minus negative 6. 2 minus 11 divided by negative 2 minus negative 6. Just bring that down here. So that's equal to negative 9 divided by negative 2 plus 6. Negative 9 divided by 4. So answer is negative 9 over 4. That's our slope. And we're going to take the point slope formula. So that's y minus y1 equals m open bracket x minus x1. We're going to substitute either one of the points. Let's just use point 1. So that's y minus y1 is 11 equals m as our slope. That's 9 over 4 open bracket x minus open bracket negative 6 x1. Don't just put x minus 6. That's a negative 6. So you have to put minus open bracket negative 6. I'm going to simplify. So that's y minus 11 equal negative 9 over 4 open bracket x plus 6. Y minus 11 equals negative 9 over 4x. And 9 times 6 is 54. So that'll be minus 54 over 4. Okay. So transposing 11, that's y equals negative 9 over 4x. Both these numbers are divisible by 2, so let's simplify that. 54 divided by 2 is 27. So that'll be minus 27 over 2 plus 11. You could just put this in a calculator to add these two. Or you could just convert 11 to a fraction. That'll be negative 9 over 4x minus 27 over 2 plus 22 over 2. We multiply the numerator and the denominator by 2. And you get 22 over 2. And then this would be y is equal to negative 9 over 4x minus 5 over 2. Okay, find the slope of the line that's perpendicular to the line segment P1, P2. Okay, the slope of the line perpendicular to this line segment here, this is the line segment we just found. We're going to find our slope, right? The slope of this line is negative 9 over 4. So m is equal to negative 9 over 4. Right, this is slope. To find a line perpendicular to that, you take the negative reciprocal. So to do that, you flip the fraction, so you'd have 4 over 9, and then you change the sign. So since it's negative, it would be positive. So slope perpendicular to this line would be positive 4 over 9. But you don't have to put the plus. I just showing that to demonstrate. Okay. So now, write down the standard form of the equation of the circle with center and radius. Okay, so the formula for equation of a circle is x minus h squared plus y minus k squared is equal to r squared, right? So all we have to do is substitute these values in. This is h, this is k, and this is r. So this would be x minus, you gotta make sure I put in bracket, negative 4, because that's negative 4, close bracket, squared plus y minus 5 squared is equal to, that's the square root of 15. That's a square, right? And now we could simplify it some more. So that would be x plus 4 squared plus y minus 5 squared is equal to positive 15. Because if you take the square root of 15 and you multiply by the square root of 15, that's just 15. So this would be our final answer. Okay, so state the center and radius of the circle with the following equation. So what we're going to do is complete the square, but we're going to reorder some stuff. So we're going to have x squared minus 9x plus blank plus y squared minus 4y plus blank. And we're going to send the 20 over. Transpose, and we transpose, it becomes positive. So x squared minus 9x plus blank plus y squared plus, it's supposed to be plus 4y plus blank. Then we send the 20 over. So now we're going to take the negative 9, we're going to square it, we're going to retake the negative 9, divide it by 2, and then we're going to square it. Right? So that would be equal to 81 over 4. That would be equal to 81 over 4. Right? So we're going to put that there, plus 81 over 4, and then over here, plus 81 over 4. I'm going to do the same thing for the y value. I'm going to divide the 4 by 2, and then square it. That's equal to just 4 by itself. So plus 4, and then plus 4. Right? So now what we're going to do is, you see the value you got before you squared it? We're going to put that into our next formula. So we're going to put x minus 9 over 2 squared plus y plus 2 squared. I got the 2 because 4 divided by 2 is 2. Is equal to, we're going to add these two together and take the square root of it. So 20, you could just put all this in your calculator, or you could convert all the denominators to 4 and then add it together. But when you put in the calculator, you will get square root of 177 divided by 4. You got 177 divided by 4, but we still have to take the square root of it. Right? So now, our center would be positive 9 over 2, because when we take it outside of the formula, it would be positive 9 over 2 and then negative 2. And then the radius would be the square root of 177 divided by 2. Because you could take the square root of 4, that's just 2. But you can't take the square root of 177. So this would be our final answer. Okay, given the function below, evaluate. Okay, so to do that, you have to find and see which domain these numbers fit in. So if we're looking for 1, right, we have to see which one of these accommodates 1. This saying if x is greater than or equal to 3. So this doesn't fit 1 because 1 isn't greater than or equal to 3. This is saying if x is less than 3 but greater than 1. This doesn't fit neither. It say that we only could use this if x is greater than 1. But this is saying if x is less than or equal to 1, or if it's greater than or equal to 4. So we could substitute this formula here. All we have to do is substitute 1 into the equation. So that's negative 1 minus 3. Is equal to negative absolute value of negative 2. Is equal to negative 2. So answer for that is negative 2. 2. This is saying if x is less than 3 but greater than 1. So we could use this to substitute 2 in because 2 is less than 3 but greater than 1. So you have 2 squared minus 2 times 2 plus 1. So that's 4 minus 4 plus 1. That's just equal to 1. Now our domain is what all of these x values, what all x values are being considered. That's how we find our domain. So the way I try to explain it is I set up a number line, right? And I just put the numbers in. So we have negative 4, we have 1, and then we have 3, right? This might not be the best way to set it up or the technical way to set it up, but it's the best way I could get someone to visualize it. So x is less than or equal to 1, so close circle because it's included, or greater than or equal to 4, close circle because it's included, right? X. Next one, x is less than 3, open circle, but less than 3 but greater than 1. So again right here, open circle. But you can't see the open circle because 3 is still included because of this. So let's attach that line, right? Next one, if x is greater than or equal to 3. So right here, and then close circle because it's greater than or equal to 3. And if x is greater than or equal to, so it's going this way and that way. This is the way I draw it solely to explain the domain of a piecewise function. Okay, this isn't the most technical way to explain it, but this is how I explain it to get a student to understand piecewise function. Now, to understand our domain is all values that are being considered. So you see we have negative 4. Negative 4 is included because it's a closed circle. So we do a square bracket, negative 4, comma, and then it goes on to infinity. You see? Even though we had some open circles here, the numbers are still included in the domain because even though they're saying that x is less than 3, right here is saying x is greater than or equal to 3. So there's still an x value for 3. It's just not this one. You have to consider this one, if you understand what I'm saying. So it would go from negative 4 to infinity. Even though 3 isn't represented by this formula, it's still represented by this formula. So it's still included in the domain, is what I'm saying. And then open circle, so that would be our domain. So it goes from negative 4 up over here, right? So in order to sketch this graph, you have to be really familiar with the library of functions. So let's see how that looks. So these are our library of functions, and you have to be really familiar with it to know how to approach these. So first, what I'm going to do is, for the first absolute value function, what I'm going to do is substitute both of the numbers in this, because this is my boundary. X is less than or equal to 1 but greater than or equal to negative 4. So I have to substitute these numbers in so I could see how far I'm graphing this on the actual graph, because I can only graph between these boundary lines, between these boundary numbers. So that would be, the equation is negative x minus 3. So substitute negative 4. So that's negative 4 minus 3. That's equal to negative absolute value negative 7. That's equal to negative 7. The absolute value of negative 7 is positive 7, but you see a negative outside here. And then the next number is 1. So that's negative 1 minus 3. That's equal to negative, the absolute value negative 2. That's equal to negative 2. And the point for these two is, you see the x value we substituted for this one was negative 4. So the x value is negative 4, the y value is negative 7. That's what we just calculated. The x value for this is 1 because we substituted 1 for x. And then the y value is what we calculated, so negative 2. So those are the 2 points we're going to plot, right? So negative 4, negative 7. So you see it goes in terms of 1, 2, 3, 4, 5. So negative 4, negative 7 is over here. And then negative 4, negative 7 is over here. And then 1, negative 2 is right here. So let's take a look at our absolute value and graph, right? If we look at the absolute value graph, we can see that it goes in terms of, okay, it goes in terms of 1, 1, and then 2, 2, and then it would be 3, 3, and then 4, 4, and then 5, 5, and then 6, 6. So this is how it looks on decimals. This is our absolute value graph look on decimals. I'm showing you this so you can actually see the pattern of it. See, kind of touching the corners, it touching like, I wish you could see, like, okay, so you see the line kind of going like this. It touching the corners of the boxes, right? So follow the same technique. It's going to touch the corners of these boxes. So we get here. And that's our absolute value plotted. So now the next one, x squared minus 2x plus 1. So when we have that, we have to know that it represented as x squared minus 2ax plus a squared, which is what the form that this is, or we could show it as x minus a squared. So what we're going to do is change it from this form to this form. It's already in this form. We want to change it to the next form. So this is x squared minus 2x plus 1. So that's x squared minus 2x plus 1. We want to put it in this form. To do that, we're going to complete the square. So to do that, we're going to divide negative 2 by 2 and then square it. That'd just be 1 squared, which would just be 1. Negative 1 squared. It'd be negative 1 squared because negative 2 divided by 2 is negative 1. And negative 1 squared is 1. So to represent that as this, all you do is write x minus 1 before you squared it, and then square. Right? So if y, even though it's a g of x, it's still, if y, g of x could be, we could also say, we could say it's g of x, or we could just say it's y. So g of x is equal to x squared plus minus 2x plus 1. We could also say y is equal to x squared minus 2x plus 1. So if y is equal to x squared minus 2x plus 1, y is also equal to this, because it's the same exact thing. This is the same formula as y is equal to x minus h squared plus k, where hk is the vertex. even though you don't see k, that's because k is 0. So our vertex would be 1, 0. That should be our vertex. So we get in places, right? So our vertex is 1, 0. So to find our other points, what we're going to do is substitute the boundary points into the formula. So 1 and 3. So we're going to substitute 1 and 3 into that formula. So that'll be 1 squared minus 2 times 1 plus 1. That's just equal to 0. Because that's just 1 squared minus 2. 1 minus 2 is negative 1. Negative 1 plus 1 is 0. So our point there would be 1, 0. And then 3, we have 3 squared minus 2 times 3 plus 1. 3 squared is 9. That would be 9 minus 6 plus 1. That's equal to 9 minus 6 is 3. 3 plus 1 is 4. So that's equal to 3, 4. So we're going to plot these 2 points. You see, this point is the same as the vertex. So we only really have 2 points to plot. And if you know how a square function look, this would be easier for you to plot. So you really have to become familiar with the square function, with all the functions and how they look. So you see, it curves up. So we're going to use an open circle because you see it say x is less than 3 or greater than 1. So since it's less than, it's open circle. Consider these numbers are not included in the answer. So we're going to plot 1, 0, open circle. And then 1, 0, and then 3, 4. So it's 1, 2, 3, 3, 1, 2, 3, 4. 3, 4 right there. Okay. And then you're going to do a curve up here. Curve up here. Okay. Now our last one is going to be negative 2. So it's just saying for whatever value of x, the answer is just negative 2. So that's just a straight line going through negative 2, starting at positive 3. So this is negative 2 here. This is negative 2 here. And then it's starting at positive 3, so right here. And we're going to do a closed circle because it says if x is greater than or equal to 3, it's negative 2. Now it's saying if x is greater than or equal to 3. So the values where x are greater than is going this way. So our arrow is going to go this way. And it's going to go off to infinity. We're going to move this to the side because this is in the way. And my pen keeps cutting off. It's getting annoying. Move this down. Okay. And that is our graph. We're going to go down here now. Okay, so given f of x is equal to and g of x is equal to, determine the following: f minus g of 5. So we're gonna solve f of x for 5 and g of x for 5 to determine our answer. So that's negative 5 squared minus 3. That's negative 5 times 25 minus 3. Negative 5 times 25. That's negative 125 minus 3. That's negative 128. Bring this over. Five So 6, 5 minus 2 plus 6. That's 6 times 3 plus 6. That's 18 plus 6. That's 24. Okay, so now it's a f minus g. So we're just going to say that's negative 128 minus 24. So our final answer would just be negative 152. Same thing over here, just substitute the negative 5 inside. So that's negative 5 squared minus 3. That's equal to negative 5 again times times 5 squared, which is times negative 5 squared, which is 25, and then minus 3. This is negative 128. And then g, that's 6 times negative 5 minus 6 times negative 5 minus 2 plus 6. That's 6 times negative 7 plus 6. That's negative 42 plus 6. That's negative 30. That's negative 36. Now we're going to have f divided by g. So we're going to have negative 128 divided by negative 36. Let's see, negative 128 divided by 36. We could just simplify them because they both divisible by 2. So negative 128 divided by 2 is 64. And then 36 divided by 2 is 18. It became positive because a negative divided by negative is a positive. And again, these still divisible by 2, so we're going to divide by 2 again. So 64 divided by 2 is 32. 18 divided by 2 is 9. So that's our final answer. So f times g of negative 3. So we're going to substitute negative 3 in the question now. So that's negative 5 times negative 3 squared minus 3. That's negative 5 times 9 minus 3. That's negative 45 minus 3. It's negative 48. So we have 6, negative 3, minus 2, plus 6. That's 6 times negative 5, plus 6. That's negative 30 plus 6. It's negative 24. So our answer would be negative 48 times negative 24. Negative 48 times negative 24 is 1,152. 1,152. And that's our final answer. Okay, so average rate of change. So the formula for the average rate of change is f of b minus f of a divided by b minus a. So they said the average rate of change of g of x from 7 to 3. So what we're going to do is g of x is 6. G of x is 6, x minus 2 plus 6. We're going to move that down here. And we're going to substitute negative 7 and 3 into the question. So g of negative 7, that's 6 times negative 7 minus 2 plus 6. That's 6 times negative 9 plus 6. That's equal to 48. negative 48. G of 3, that's equal to 6 times 3 minus 2 plus 6, that's equal to 6 times 1 plus 6, that's equal to 12. So f of b, this is a, and this is b, right? So f of b will be g of 3, which is 12. So that's 12 minus f of a, which is 48, so minus negative 48. See, I put the minus and then a negative in brackets because that's a negative 48 divided by b minus 8. So that's 3 minus negative 7. Okay, so that's equal to 12 plus 48 divided by 3 plus 7. So that's equal to 60 divided by 10. So our answer is 6. Okay. Now the difference quotient of f of x. Note, they give you the formula, so they might not. So remember what the different quotient look like. Okay, so f of x, let's write f of x. So f of x is equal to negative 5x squared minus 3. Right? So we're going to move that down here. Right? Solidifying f of x plus h, because you see we need f of x plus h. All we have to do is substitute x for x plus h. So that's equal to negative 5 x plus h squared minus 3. So that's equal to negative 5 times x squared plus 2xh plus h squared minus 3. I got that by just multiplying the x plus h squared out. And then you could just distribute the negative 5. So that's negative 5x squared minus 10xh minus 5h squared minus 3, right? So now we can substitute everything into the formula because we have everything we need. So that would be f of x plus h, so negative 5x squared minus 10xh minus 5h squared minus 3 subtracted from f of x. So we're going to put the subtraction sign, and then we're going to put f of x in brackets. This is important. Minus 5x squared minus 3 divided by h. Now we're going to distribute this negative to both terms. That's minus 5x squared minus 10xh minus 5h squared minus 3 plus, we're going to distribute this negative. So that would be negative times negative 5x squared, which is plus 5x squared. And negative times the 3 would be positive 3 divided by h. See? Now if we look at this, we could see that some terms cancel. This 3 and the negative 3 cancels, and then the 5x squared, and then this 5x squared cancel. So we're left with negative 10xh minus 5h squared divided by h. Right? We're left with that. Okay. Now, if you could see, h is common in both. If you can see, h is common in both these terms. So we're going to factor out h. When we do that, we're left with h. We're going to have negative 10x minus 5h divided by h. The h's divide into itself. So all you're going to be left with negative 10 x minus 5h. And that is your final answer. Negative 10x minus 5h. Okay. Next page. Given that negative 9, 6 is a point on the graph of y is equal to g of x, what point is on the graph of y equal to g, open bracket, x plus 5 minus 7? The way I like to determine it is, I like to set it up as if I'm already going to do a transformation, because this is 10 transformations what we're doing right now. So, when we're dealing with transformations and it's set up like this, when you see the negative 7 over here, this 7 is being subtracted from the y value. So, y minus 7. And then you see this x plus 5 here. When you take it out, you're not actually adding 5 to the x value. You're actually subtracting 5 from the x value. So this is going to be x minus 5, right? And what are our values up here? X is negative 9, and then y is 6. So we're just going to have negative 9 minus 5, and then 6 minus 7. So our answer is, what point is on the graph of this would be negative 9 minus 5, which is negative 14, and then 6 minus 7, which is negative 1. That's our answer. Same thing over here, so we're going to set it up. Okay, so y, you see this 3 on the outside. So y is being multiplied by negative 3y. Y is being multiplied by negative 3. And then we're adding 4 to it. And what would this be? This would be x plus 5. Because when we take it out, we're switching the sign. So x plus 5. So this would be negative 9. This would be negative 9. This little dot was a mistake. This would be negative 9 plus 5. Y is 6. So that would be negative 3 times 6 plus 14. So the point for this answer would be negative 4. Negative 3 times 6 is negative 18. Negative 18 plus 14 is negative 14. Okay, this graph. We're going to do, we could see 3 is a common factor in both. So you want to always make sure that your x has a coefficient of 1. So we're going to factor out 3. We're going to leave left with x plus 2. G. Okay. So now that 3 is actually affecting the x value. But you would think that we multiply the x value by 3. No, we're dividing the x value by 1 over 3. So 1 over 3 times x. And then we're subtracting 2. So you divide the x value by 1 over 3, and then you subtracting 2, because remember, we're not doing what it actually says. We're doing the opposite of what it says. And the y value isn't affected, so we just have y there. So this would be 1 over 3 times negative 9 minus 2, and this would just be 6, because the y value is 6. Okay, so negative 9 times 1 over 3 is negative 3 minus 2, which is negative 5. So our answer is negative 5, 6. And those are answers. Okay, now describe the transformations on the graph of y equal square root of x to obtain the graph of that, right? So you have to be really familiar with your transformations. So this 5 is affecting the x value. Remember, we wouldn't be adding 5 to our x values. We would be subtracting 5 from our x values. And when we subtracting from our x values, the graph is going to the left. So we're shifting left 5 units. So we're shifting, shift left 5. Right, the next thing that's going to happen is the y values are being multiplied by negative 3. So you're reflecting across the x-axis, because if the y values are being multiplied by a negative number, let's say the y value up here, right? When you multiply it by the negative number, it will go down here. Because remember, our y value is positive up here and a negative down here. So if you multiply a positive y by a negative number, it will go down here. So you're reflecting across the x-axis. And remember, this is the x-axis. So you're reflecting across it. So next thing that's happening is you're reflecting across the x-axis. Next thing that's happening is a vertical stretch by the factor 3, because like I say, you're multiplying it by negative, not only the negative number, but it's 3. So you're stretching it by 3. So vertical stretch by 3. And then the last thing that's happening is you subtracting 7 from the y value. So you're shifting it down. So you're shifting down 5. Shifting down 7, sorry. Okay. Okay, and this is the last page. Okay, so this is of the formula a, open bracket x minus h squared plus k. The vertex is hk. So to find our vertex, all you have to do is take the 7 out. And when we take the h out, you flip the sign. So instead of negative, it would be positive 2, and then just 7. You don't change the sign for the number that's over here. It stays the same. So our vertex is 2, 7. Our axis of symmetry is just our x value. Our axis of symmetry is x is equal to h, so whatever the h value is. H is 2, so our axis of symmetry is x is equal to 2. The graph opens down because it's a negative number. It's a negative. You see this negative up front here? Because there's a negative up front here, the graph opened down. If it was a positive, it'll open up. So because it opens down, it has a maximum. And our maximum value is 7. To find our y-intercept, all you have to do is substitute 0 for x and then solve for f of x. So we have f of 0 is equal to negative 3. 0 minus 2 squared plus 7. That's equal to negative 3. Negative 2 squared plus 7 is equal to negative 3 times 4 plus 7. That's equal to negative 12 plus 7, which is equal to negative 5. So our y-intercept, x is 0, and y-intercept is 5, right? So to graph it, it's quite some things. First, you need to actually know how the graph of x squared looks and the points that are actually on the graph of x squared. So as I say, you really need to know your library of functions. So you need to know these points that are on these graphs. So points that are here are so we have negative 2, 4, negative 1, 1, 0, 0, 1, 1, and then 2, 4, right? Okay, so this negative 3 this negative 3 affects the y, and this 7 affects the y too. So negative 3 is being multiplied by y, and then 7 is being added to it. And then x, remember when you take it out, it's positive because you're just flipping it. You're actually doing the opposite of what it says. So that'll be x plus 2. Okay, and we're just using these values down here. So this would be x plus 2. So negative 2 plus 2 that's 0. And then 3 times, so that's negative 3 times 4 plus 7. So that's negative 12 plus 7, be negative 5. Next one, that'll be negative 1 plus 2, that's just 1. Next one, that would be negative 3 times 1 plus 7, that would be 4. Next one is 0 plus 2, that would just be 2. Next one would be 3 times 0, which is 0, and then plus 7, so that would just be 7. So that would be 1 plus 2, that's just 3. Next one, that would be negative 3 times 1, negative 3 times 1 plus 7, that's negative 3 plus 7, that is 4. Last one, that's 2 4, so that'd be 2 plus 2, which is 4, and then 4, so that's negative 3 times 4 plus 7, that's negative 12 plus 7, which is negative 5. So the first point is 0, negative 5, 1 4, 2 7, 3 4, and then 4 negative 5. So we're just going to plot those points. So remember our vertex is 2 7, put it already here, so we just plot everything else. So 0 negative 5, so that's where y is negative 5. 1 4, so 1 4, 2 7, so 2 7, 3 4, 3 4, and then 4 negative 5, 4 negative 5, right here. You know you do this, you know you're doing the right thing when the axis of symmetry actually matches. So we're gonna draw the line to connect the points. Supposed to be a little curve to the top. So a little curve, like that. Okay? And you know you're doing the right thing when the axis of symmetry. So the axis of symmetry is the line where it actually reflects. So if you were to divide it in half by this line, it would be the same thing, right? And if you see, it kind of technically is, because, see, it's directly in the middle of the vertex. And then this one, and this one, you see, it's even distance between the points. So that is the axis of symmetry. And that is the paper. Thank you so kindly for watching this video. If you're not on the broadcast list already, or if you're watching from the future, please WhatsApp this number below to be added to the broadcast list. So whenever other resources come out to be able to help you with your assessment, you'll get access to it, okay? Thank you so much for watching once again. Share this with a classmate, and all the best in your tests. Bye!